I think there are some real epistemological differences in the way that those different information technologies can be deployed in research. And I think people have a kind of, even people who don't, for instance, themselves design database schemas and write SQL code and so on, they can still nevertheless have an idea about the ideology, if you like, of databases, and they can understand relational databases without themselves being able to, say, create one, and query it, in SQL. And I think the same sort of thing applies to RDF. And I think people who can understand RDF, at least, as Ingrid's presented it, as a graph model, and understand the implications of that for how you can represent knowledge, without yourself having to get in and write, RDF triples. That's a different matter, but it's important to understand the capabilities of the technology, I think, in order to be able to collaborate with the technical people who can actually do the, the nuts and bolts work. So anyway, that's me. So, yeah, I've got a mouse too. So I'm going to slightly recapitulate some of the stuff that Ingrid's said, but I'll speak very quickly. So RDF, it's a data modeling framework for describing resources. Resource description framework is what it stands for, so that's what it's for. It's about describing resources. But what is a resource? In RDF terms, a resource is anything at all. Literally anything can be a resource. So that includes all sorts of things. Resources are identified always with a uniform resource identifier or URI. Okay, the sort of thing that you see in your web browser is the unique identifier always. So there are two kinds of resources in RDF. Information resources, so things that you can download off the web, like videos or web pages or databases or whatever. And then there are non-information resources, such as people, abstract concepts, places. The kinds of relationships that can occur between resources are also the resources. So all of those kinds of things are regarded as resources by the resource description framework, and they have HTTP identifiers, even though you can't actually download one. You can't download a person, obviously, off the web. So RDF is made out of triples, as Ingrid said, so you're basically linking two things together via a third thing. Okay, subject and object, and the predicate in between, which is, if you like, a relationship or like maybe two nouns and a verb, that sort of thing. So the things that are linked are resources, so they're identified by URI, but some of those things are called literals, literal values, and they are things like numbers and pieces of text, dates, kind of raw, if you like, raw data. And so here's an example of an RDF graph, this is one that was I sketched on the side of my fridge, and it's part of the Honey data set, and it's about a person X here, who has these three web pages that are about them. So person X has web page A, has web page B, etc. The web page has got these properties which are literals. So person X and pages A, B, and C are resources, and then these titles and so on are literals. So basically, an RDF graph is just a collection of triples, and essentially, because the triples are resources that are linked together by these other resources, if you get a whole bunch of triples together, they actually form a network or a graph. So the word graph here is used in a mathematical sense from graph theory and mathematics to mean a set of nodes connected together by lines or arcs, or a network, what people would normally call a network in colloquial language. Okay. So an RDF ontology, essentially it's a formalised technical vocabulary. So there are ontologies for all kinds of things, and the ones that Ingrid showed, Dublin Core, for instance, which is a kind of a bibliographic ontology for describing published resources. So you have a vocabulary which has terms like publisher, date, creator, those sort of things, title. And so that's, if you like, a technical vocabulary drawn from the library world. But then there are other technical vocabularies that are scientific in nature, and that deal with all kinds of different specific domains. And in the Honey project, we're having to merge together a whole bunch of ontologies and use them together. And that's actually quite a common thing to do. People in the RDF world do typically use kind of a blend of ontologies, and they'll pick a bit of this vocabulary and a bit of that vocabulary in order to, just as we do speaking in natural language, in order to build a kind of a coherent whole. So linked data. Linked data is essentially a technique, a specific technique for publishing RDF on the web as graphs. And so the guts of it is some of the URIs the identifiers that appear in an RDF graph, okay, in a triple, in a graph, refer to information and resources. And if you click on those in your browser, you can download that resource, or strictly speaking, download a representation of that resource. So you can see, you know, an image, or you can something in your browser. But the other resources that are non-information resources, you can't download them, obviously. And I'm going to give you an example based around the Yarra River. And you know, if you could click on a URI and download the Yarra River, you end up flooding your room. It doesn't make sense. So what you get instead, because these are URIs, I mean, you can put them into your browser and you press the button. What does happen? You know, obviously a river doesn't come out. Instead, what happens is the server, it knows that the resource that you've requested is a non-information resource. So instead of returning a response for the URI that you requested, it sends you another URI saying, see this other URI. I can't give you that because it's not an information resource, but I've got this information resource which is relevant to it, and then your browser says, okay, send me that, and it sends a request, send me information about that resource, and then you download information, say, about the Yarra River. And so what this technique, the linked data technique, it basically enables a kind of an exploratory technique for people who are consuming data. They can navigate their way around a graph, download representations of things, and those representations will contain links to other things, and you can kind of navigate your way around a cloud, if you like, of data. So that's linked open data, the technique, but linked open data is an actual social movement out there on the internet where people are starting to build, you know, collaboratively build this cloud where people are contributing data sets into the cloud. And for data custodians, people who are actually publishing data, the technique offers a lot of advantages. It breaks down silos, because once you've put your data out there and the things that, you know, that are part of your data are identified by URIs, other people can also make statements, triples, which include those URIs, and they've enhanced your data set that way. It's basically a way of breaking down and dissolving the barriers between those data sets. It means that third parties then can add annotations. So if we've published a piece of data about Ingrid with an Ingrid URI, someone else can come along and make another statement about Ingrid, and they've enhanced that data. People can also then join two other data sets together. So let's say, well, this is the case in the Honey project, we have some of our partners will have made some statement about a resource, some other partner will have made some other statements about another resource, and then another partner will say, actually these two resources are the same, and make another statement to say, this is the same as that. And then the statements that have been made about those two are effectively merged, and so you've actually joined those two data sets together, independently of the publishers who published those two data sets. And the important thing I think about the use of graphs, because these triples are bundled up in graphs and published independently, is that you can at least see, you know, where those triples came from. What was the source graph? And you can decide then whether to trust that graph. Well, it came from one of the scholarly, you know, published data sets. I'll give it the benefit of the doubt. Or you might say, I don't know who published this. I'll just treat it with a pinch of salt. So really, that's where, you know, tracking the provenance of those triples and attaching that provenance to the graphs that contain them, you know, the source graphs, that's really key in order to be able to treat the data and to know what kind of level of trust to put into it. Okay, so I'm going to give you an example with some data from Wikipedia. Now, at the end of our Honey project, of course, we'll have a huge linked open data set based on, you know, Australian humanities data, but for now, I'm using Wikipedia for this little example. And I'm going to show you DBpedia, which is a linked open data source which is derived automatically from the articles in Wikipedia. So you may know that in Wikipedia they have these little things, fact boxes or info boxes, whatever they call them, on the summer pages at least, where you can enter quite structured data. So if you've got a page about a city, you can write all sorts of stuff about the city, but in this structured portion of the page, you can write the city's population, you know, its geographical location, those kinds of structured facts, if you like. And so what DBpedia do, which is this project associated with Wikipedia, is they transform the data that's been entered in those parts of the page into RDF, and then they publish it through a linked open data store. And they also publish it through a Sparkle query interface, which I'll show you. So have a quick look. This is, I don't know if you can read that URI, but it's the Yarra River. Okay, this is the Yarra River. Okay, so this is the Yarra River, and you can see here it's basically a bunch of page with two columns, okay, and effectively this is a list of triples, okay, because the subject of all these triples is the Yarra River. All of these triples are about the Yarra River, so that's why there's no subject column, because it's all the same, okay. But then the property is the predicate, and the value is the object. Okay, so this is basically a list of all the triples that have been derived from Wikipedia, in which the Yarra River is the subject. And so you can see here, look at this property here, it's got DBpedia OWL abstract, which is a bit of an article, but there's a whole lot of things like here. It has tributaries, okay, these are all tributaries of the Yarra, and these are all links to then other resources which identify those other rivers.